Good afternoon, ladies and gentlemen. I hope you can hear me. That's quite a high-energy introduction, so I hope this session will be full of that kind of post-coffee energy. We have a very interesting topic to discuss this afternoon. We have four very interesting speakers. They have a lot to say. We have an hour and a half, which seems like a lot of time, but of course, as we all know, it's not. So I'll be very brief for my own little introduction. And then we'll also try and make sure to get some questions in. I am, of course, to remind you to use the Slido device or app to put some questions forward, but please, of course, use the microphones because there's only so many of us in the room, and it would be nice to have a bit of a discussion after the presentations. My name is Patrick Kennedy. I'm the Communications Advisor with EFRA, that's the European Factories of the Future Research Association. We promote the EU's Factories of the Future Research Innovation Programme, which has a substantial budget, which over 7 years hopes to help transform manufacturing. You can find out more about that on our website, which is right there. There are call topics for research innovation projects open right now, so again, if you go to that website, you can find out more about it. So to introduce our speakers, I will quickly go through who we're joined by today, and then we'll get straight to the presentations. So on the far left even, is Michaela, who is Chair of Innovation Ecosystems Working Group of the Alliance for the Internet of Things Innovation, which is a body set up by the EU, so that'll be quite an insight. I have Jacopo Casina, who's actually in the middle, I see you've moved around, who is the CEO of Holonics, a very successful spin-off from Politecnico di Milano. And then back towards the left is Václav Mák, who's Director of Government and Corporate Affairs in CE from Microsoft. And finally, Juri Tabak, who's Senior Specialist of Local Strategy and Development at T-Systems here in Slovakia. So if we can start with Jacopo, who'll give the first presentation. Thanks.
Okay, thank you. And as soon as the slides will be on. Okay. As introduced before, I'm from Holonics. We are a startup in Italy, starting from Politecnico di Milano, which is a university, and we focus on managing the life cycle of things, so getting the information from sensors, tracking and so on, and managing them from the whole life cycle. Coming here, I was thinking, but we are talking about reindustrialization of the European Union here. What can I add in this discussion? Actually, I thought to a question I made some time ago when I was at the very beginning of the Holonics journey at CERN. I asked what was evaluated like a kind of nasty question. Since there was there the team who created the internet, the first version of the internet, and I asked, internet was born here, but now all the money are made in US. Any suggestion how to avoid it again with the Internet of Things? So what can be done? And actually the answer was pretty obvious. Well, it's not our job, it's entrepreneurs' job to keep it in Europe, not in US. And actually I don't completely agree with that, because entrepreneurs' job is to make the best profit, not to remain in Europe. So I was thinking, what is needed to keep manufacturing IoT enterprises in Europe? This is my sector, so I try to answer from that perspective. IoT is rising, so many of the aspects are similar to those that are also needed for an SME. So again, I try to make an idea. First of all is the ecosystem, and I think here is something that we are working rather well about, because to create IoT for manufacturing companies, we need manufacturing companies, because it cannot, when you talk about manufacturing, you cannot really do anything for manufacturing companies without visiting their shop floor, having the experience and the dirty hands on what they really do. Second point, compared to US, is the market. US is a single market, but now also in Europe we are trying to work on it. And communication and culture. Many entrepreneurs, many old companies, traditional manufacturing companies, doesn't know anything about Internet of Things and so on. And usually is lacking a shared vision. But, for example, I always joke that Angela is one of my favorite people, because with Industry 4.0 she made understandable by everybody what actually Internet of Things is, what Internet of Things can do for enterprises. Then, for the shared vision, actually, there are several projects that are working on visions for using Internet of Things in the enterprise. I just cite here one, that is Scorpius, that I've been working on together with a large team from all Europe, that try to define the cyber-physical systems and evaluate a model to analyze the manufacturing companies in the ICT landscape with two sections. One that was the product section and the other was the factory sections. Then the next step is to experiment and seed. Here I will try to make some examples with our experience because, you know, we have to try innovation, and I think European projects are a very good tool to try to experiment innovation, to make prototypes. And obviously sometimes prototypes fails, but then you have just to try again and make it better. Just going to a product section, I will make an example. We are currently working in a project that is called the Manutelligence, where we are working on the Ferrari FX6K. One of the advantages of being Italian is that we often can work on very nice stuff. Actually, Ferrari is a product service. This Ferrari is a product service because when you buy it, you don't really buy the car, you buy the Ferrari plus the pleasure of running it on a circuit. So you pay some millions euro and you get both the car and the service. Obviously, since it's an exclusive service, you have to own at least 5 more Ferraris before buying this one. But this is obviously not a problem for those who use them. The car itself is a lab. It's a lab to improve next Ferrari's generation. And the whole program is a test bed for innovation. So they try very strange things, whatever they can add to a car, used also in real life, but to run as fast as possible. And customers are the product testers. So it's not a professional pilot doing the testing, but is a customer. What's the difference? Ferrari Enzo was made with Michael Schumacher. Ferrari Enzo was as fast as hell, so nobody in the real world was really able to drive it. So with them we did this cycle. They do the prototype, the Ferrari car prototype. We do data acquisition with Internet of Things devices. Together with the Dassault system, we prepare the data for the simulation that is performed on their platform, cycling design several times, improving the design itself up to a result. This was some of the screenshots on the testing. We made testing on how to avoid vibration on the driving wheel, because you are going 350 kilometers per hour. If the driving wheel vibrates, actually you slow down. So that won't be nice for a Ferrari owner. Dassault took the data from the real experiment and made a simulation based on the input from the real world and compare it with what was getting out from the simulation itself, tuning the model and being able, therefore, to use it for improvement. Another example is in the factory section. I have made 2 examples here. One, in another project that was called the Link Design, we worked on collecting data from the production line to improve the quality of the product itself, making the data of the product very easily available to whoever was willing to work on the product quality. Actually, we started talking after with customers, using this as a prototype to show up to customers, seeing if they were interested to take it. Actually, we found one customer who was interested in that, and actually we sold it. And so we developed a first version of the product. But we noticed that overall it was still too immature to really go to the market. So we are working and doing more research on that. Actually, it is not a failure, but almost. While another example, another use case of the same project was mainly on acquiring data from the machines and linking the user of a machine and the producer of a machine, so to make a better maintenance together and enable the producer of a machine to understand how the machine is really used, so to perform better design in the next iterations. This one derived with some investment, almost 6 months of work of investment from our side, to a commercial solution that is called REinEU and machine monitoring. One is the app, the other is the platform. That is for users and for producers. Actually, we managed to have a machine producer that is called Haas, who installed it on the machine sold in Italy. So, this one is getting to the market. Then, actually, these are all first trials, first results. To really stay in Europe, a company should grow here, scale up here. And that's also where the Death Valley often is. And I have to say, it's a really tough work. I have an example here. We worked, in the very first project we entered, we work on the boating industry. As I said before, in Italy we have a lot of nice stuff, so I like to work on them. As you maybe noticed, our platform is called I Like, and so I like many nice things, cars, boats, food, and so on. The iCaptain is the solution thought to the nautical market. I Like is for the production of boats. We managed to produce the platform, to manage the vessel in its whole life cycle, integrating with production, use, and maintenance, with 2 points of view, the captains and the shipyard. As you see, it's pretty similar to the machine example. We managed to have a partnership with the boat producer that is installing them on all its product, and with an insurance. But even with these good inputs, we found out that going to a market is not easy at all, because a proof of concept on the IoT has a limited area, limited scope, limited number of devices to be connected, limited problems, not too stupid customers. While when you go to the market and give them to everybody, then you really achieve results that are not easy to be planned. Such people who just drop water on an IoT device when it's open, and then magically it breaks up, and things like that. And we also got an unexpected result, since we thought the solution for the small boat market, mainly, with an extension to the middle one, while we got very nice interest and success from the large vessels. So now we have a contract with Perini Navi that is producing ships, leisure ships, these ones. These are 110 meters long ship for pleasure. And we are working with them to equip them with IoT devices. So starting from a small, at the end we found out the IoT was more interesting to the big. So the initial question was more or less, is it possible to keep manufacturing IoT in Europe? My answer is that is a difficult battle, because at the end of the day, in many countries there are startups working on this topic and going farther on this topic. But we have good tools, we have a good position because we have a nice good ecosystem. Many manufacturing companies are based in Europe and are advanced manufacturing companies. The European Commission, with the tools that is providing us, actually is providing a good input that is improving over time, and I hope it will improve more over time. Some of the tools helps us to arrive to a certain point, then the last mile is obviously up to us. Some of the tools should be improved. For example, I would love a better communication of the different aspects, because for small companies it is impossible to make the whole public understand what IoT is or what nanotechnology are and so on, while if this is done at a wider level, is a kind of communication and teaching of new possibilities that would be very useful to everybody, to all the ecosystem. The European projects actually helps a lot to try and enable you also to fail, honestly, while the last mile is obviously up to us, and we have to believe in it and do it. Because if we don't believe it and don't try as hard as hell, it won't happen. So that's all from my side. I was even too fast. So strange enough. That's it.
Thank you very much, Jacopo. So we'll go straight from the product kind of centered perspective to more strategic centered. Yuri, please.
Okay, so it's a pleasure to be with you here. I am from the, my name is Juraj Tapak. I'm working as in the department of the local strategy of T-Systems Slovakia. It's a IT service company where is currently working about 4,000 people, supporting infrastructure in different European companies, mainly for big plants, big production, and other companies. So we can say that Internet of Things is already here. Yes, we can understand the Internet of Things like big ecosystems which consist of data, virtual space, cloud, sensors. So it is the connection of the business, customers, to the goods, assets, equipments with the embedded devices in the internet. Specifically, I will move to the industry internet and industry 4, because then we are talking about Internet of Things in the industries and services, and in the industry 4 we are talking about Internet of Things in the manufacturing industry. T-Systems is participating already in some good examples of implementing Internet of Things with in his ecosystems, where he's helping the companies to really move to different business model. So first I will mention a company which is automotive company, but has business which is related to the fleet or transport management, and working together by the integration of the fleet management, by taking the data, operational data, maintenance data, we create a system which is able to provide a service and give substantial savings. It's about 20% of the fuel stock. And as a service providers, we are helping this company to do this new business and have a revenue. The second example, it is another company which was in the past a very big petrochemical product provider. Now is working in the new energy sector and distribution. And together with them we create a system providing collaboration tool for 90,000 people, have one access and also analytics, so really they can provide this service very, very efficiently, globally. Another nice example is working together with aircraft manufacturer, famous European aircraft manufacturers, where we develop the intelligent luggage, which is traveling separately from the traveler, and it's enabling to reduce the cost in the cabin, because you don't need to because it's traveling separately, you are able to see where the luggage is, and if, for example, somebody is thieving, so a lot of services there. So what we can say that the Internet of Things will transform the business from selling product to product service. Product service, that's first point. Then the production by using intelligent sensors with computing capabilities will provide the self-maintenance system, avoiding stopping the lines and reducing the maintenance cost. And what is very, very much interesting, because I have also worked in big machinery plant, it will allow to very fast change the production portfolio or products in the lines, depending on the customer needs, or if something happens in the machine or machinery, or if there is missing parts, normal situation in the plant. So with this type of technology, really the plants could be very, very flexible. It is also interesting that in 2020 there will be 200 billion smart devices on the world, but 40% of data streams will come from sensor in cars, trucks, and production machines. So how we see the Europe, yes, in the industry of 4? We are convinced that because Europe has very good strength in some type of production, cars, airplanes, and some other stuffs, like production of machines, that really we have very good potential for the innovation and be on the top in the global competition. And it is also possible. It is possible also this bring to small and medium enterprises, not only the big one. Specifically, for example, for Slovakia, it is interesting that because of transferring and developing a lot of new industry like car and industry, here is the plants are quite new, yes. So we have a good base to start these new smart factories. Of course, it's much more difficult in the countries where there is old technology, and this has to be removed. So where we see or the key elements for digitization in the industry, that's analytics, yes, then mobility, and cloud computing, What we are providing is for our partners are the dynamic platforms, dynamic networks, and what is very, very important, it's end-to-end security. What is really necessary for IoT are the new models, new product service models, and here, specifically speaking about Slovakia, I see some deficiencies because those are the new business concept, new models, and the university still, let's say, are teaching obsolete stuffs, and industry should really help to that. And on the other sides are the partners with whom, as a service providers, we are doing the integration and transformation of the business. So some implication, it was already mentioned in the preliminary session, yes, it will have a big impact on the workforce, yes, because many jobs due to IoT in the plants will disappear, but also many jobs will come up, much more knowledgeable jobs and with the higher skills. And this is a big challenge to education system and also the industry as itself, because education by themselves are not able to respond to that challenge. Industry must help to define the needs for new skills. And the last thing about what I want to talk is showstoppers and challenges. So first are the standards. Yes, there must be done a big work on the standardization. It is not easy to connect sensors and equipment to old legacy IT systems, so standardization is really crucial in this area. The second point is data privacy and security. Yes, for industry and plants, this is very important because if and there are already some known cases when there were some hacking to the systems, and the production, there was a big loss in the production output. And third point is tremendous big data flow from the sensors, agents, hubs, yes, to networks and to clouds. So the only way how to manage is that there will be some sensor computing, so the sensors will have some computing power, and they will make data processing and send only compressed data to the clouds. Okay, so that's all for me. Thank you very much.
Thank you very much, Yuri. Vaclav, as I invite you to the podium, I would like to remind the participants, who I'm sure are bursting with questions, that you can already start putting your questions into the Slido online, and we'll be bringing that up in a little bit. Well, actually, we're doing it now. But we'll be coming back to those after the presentations have completed. My smart device here seems to have actually already ended its life, but I can assure you I have a smartphone on me, and I'll be looking at these questions, and I'll be picking them out shortly. Please go ahead.
Thank you, Patrick. So let me start with something which is called Cloud for Global Good. If you have been here, and most of you have been here because the saal was full here for the plenary session, then Peter Droll from UDG Research and Development mentioned that if we means as an industry, academics, if we have some proposals how to fool the policies for cloud, then we should bring to their attention. And Microsoft was a company who was developing the kind of narrative called Cloud for Global Good. Can you just show me where okay, here it is. There is a presentation, Cloud for Global Good, which is something what I would like to introduce you. But starting with that, let me start with what is the cloud. And this is just the one step back. We live in the amazing time. Technology is changing our lives with a really huge speed. The progress in medicine, in education, in communication, in productivity, it really increased the life expectancy around the globe and lifted hundreds of millions of people from the poverty, and they are moving to the something which is fueled by the cloud. The ability of connect people, give them the information, it instantly growing people, and we just take it as a granted that it is something which is here forever, but it is not. I would like to show you the two pictures. I think maybe you recognize this is the New York, well-known street at the Broadway, and the year which we see in this historical picture is from 1905. What you can see on the picture is that horses are primarily the mode of transportation. On the second picture, we are just 2 decades after. It is the year 1925. Automobiles fill the streets. But between those two periods, the profound transition happened. All of the horses were replaced by the automotive industry. All of the people who were taking care about the feeding the horses, about the driving, the transporting the things, they disappeared. Most of them, they lost their jobs and they have to transform. And the society, which was moving by the speed of cars, was in those days trying to develop the new legislation. The people, they were with the flag, take attention, the car is coming. That was the first new legislation developed for this transformation. So we lived in the time where the digital transformation, in fact, is the fourth industrial revolution. The first industrial revolution was driven by the steam engine. Then the second industrial revolution, that was the change of the horses with the power plant electricity, with the engines. And the third revolution was done in the microprocessors. It was the time when Microsoft was born, when the first PCs, with the vision of having the PC in each and every living room, was developed, and nobody believed that that will be the true. Now the mobile phones which we are having, each of us, and who from you doesn't have a smartphone, the capacity of these phones is much bigger than what was the capacity of the computing power when the NASA was leading the spaceship to land at the moon. And we are capable to have and use this technology. So the fourth revolution, industrial revolution, started by the era driven by this transformation and this change of cloud computing. The heart of this transformation lies in cloud computing. Everything is powered by the cloud. Cloud is just the 100 of the data centers. Doesn't matter which vendor will be providing the capacity in the data center. Before me, you have seen the presentation of T-System. They are one of the partners which is providing the trustworthy maintenance of the data center run in Germany for the European governments and European public sector customers primarily, who takes a lot about the data privacy. But the cloud itself is bringing huge benefits, enormous benefits. The future can be in eliminating the poverty. Diseases can be eradicated. The solution for the climate change can be discovered by the power of cloud. But cloud also is representing the disruption of the economy, of the classical business models, which will be not working anymore. Let me give you a couple of examples, or maybe just some of them. Today, in the morning, I was just simply trying to take a taxi, but I took the Uber. And the reason for that was not that the price of Uber would be in Prague or in Bratislava cheaper. It was because I would like to have a capacity to know when my car will be coming. I don't want to keep any recipe. I would like to have it in the electronic form. I don't want to take care about and spending my time when I'm ending at the destination and paying, because my invoice will be already charged to my credit cards. All of those benefits are simple, but for me as a consumer, they are enormous. And for the driver, of course, he's sitting in the car, having the Liftago, Uber, maybe still on the plain old telephone, somebody will call him from the dispatching, but he don't wait anymore to be reliable on the old call center and the taxi company. He just simply would like to wake up and say, not today, not now, I have to go with my child to the garden school, and I will start work when it fits to me. Then he is connecting, and then he is driving. Those benefits can be enormous, but it is just one of the examples. Airbnb, the biggest hotel accommodation company with having no hotel. The Uber, the biggest taxi company having no car. And this is a digital transformation. Microsoft is also active in the helping researchers in develop the things which really can make a significant impact. The research can, for example, help to eliminate the cancer, and there can be found many other examples where the cloud could be in the heart of the research and development. But with the opportunities, the challenges are coming as well. The challenges are for Uber that the taxi drivers, the whole industry will just simply don't like to transform as they are. They will be much slower, and they would like to use the existing legislation to stop the competition. They don't want to transfer the existing legislation to the new technology and disruptive technology which is already here in place. Airbnb, again, they are facing the competition from the hotel industry. They don't want to be treated as an unfair competition, etc., etc. That can be found many other examples. Why we are talking about the Internet of Things and how the Internet of Things are fitting to this industrial revolution, fourth industrial revolution. There will be a huge number of different devices which will be connected to the internet. It not necessarily has to be the smartphone only. It will be your home, your car, variable, whatever you will think will just generate the huge amount of data. And the question is what the data will mean, if it will be for the benefit or for the threat of us as a citizens and users. By the way, there was a study which was trying to calculate in average how many devices are connected to the internet. So how many Internet of Things are generated every second. Do you have any idea? Every second? 5, 10, 50, more, less? 127 Internet of Things connected every second to the internet. It gives you a lot of opportunities. In the city, you can just simply think what the Internet of Things can bring, but there are many challenges as well. So far, we are not facing those huge attacks on the DDoS, attacks from the botnets or whatever could happen, but we have to think what the challenges should mean. Fitbit or whatever the band will be called, which will measure your data and help you to improve something. It gives you still some data. It is Internet of Things. It is nice to have, but it is not critical. So who care? In my freezer, I can scan what is in and I can have the nice analysis and statistic. Maybe some food will be destroyed, but who care? In case if the Internet of Things will be in the cars, it's a different story, because it can have a fatal results. If the Internet of Things and the attacks would go to my house, it could be much more danger. And within the smart city, again, it should be something which really make a significant difference. And we have to say, those things are here right now. The others, they will come soon. And because of that, we have to think what the new legislation will be and how we can improve it. And once we are talking about the Internet of Things, we have to also acknowledge that we must work together to create a future which will benefit for everybody and nobody will left behind. Microsoft developed this narrative which is called cloud for global good. I think if you will put in any of the browser those three words, you will find an online recommendation with policy makers for 15 categories of where we see the challenges, what we see as an opportunity for the industry, and what the concrete recommendations within the policy should be taken for Europe to be competitive on the global market. We just categorize those total 78 areas and 15 categories to the three main principles. We have to develop cloud, which will be trusted. Trusted means that, like in the bank, if our customers would not trust to the bank that they will take their money seriously and they will not steal them, if they will not trust us as a cloud providers, they will not use our services. The trusted cloud means that we have to take care about the personal privacy of our customers. We have all around the world work on the standardized systems which will be protecting the cybersecurity and the standardization of the processes which are managing the data in the data centers. Policies will have to guarantee also the free flow of the informations, but they have to respect the national borders as well. So it will generate a lot of challenges for the policymakers. We have to develop the cloud which will be also responsible. And responsible, it means that we have to think about the environmental practices and the impact of the so many data centers which are powered by the energy. We have to think about our commitment, the transparency, and we definitely have also to think about the people which will lose their jobs because of the digital transformation. And there will be a lot of those people which will have to change, which will have to transform together with this fourth industrial revolution. Together with the other challenges and the policies needed for the artificial intelligence, we will have to develop the policy recommendations, and because of that, we developed this Cloud for Global Good as some beginning of the public policy discussions. At the end of the day, this is again something which is the definition used for the Internet of Things, and I'm coming back to the Broadway. This is the same building 100 years after the first and second revolutions, industrial revolutions happened. We are seeing the same buildings, nothing was changed. Of course, we don't see so many cars as it was at the beginning, but we see so many people. But behind it, there is 100,000 of informations and millions of bytes exchanged between those communicating people. Like in the horses and motor vehicles 100 years ago, the similar revolution will happen 20 years from now. We don't know what will be in 20 years from now, but we have to be sure that we can be proud of the policy changes we've done in the past couple of years. And by the way, during the last 40 minutes, so many new devices were connected to the internet. Thank you very much.
Thank you very much. I think you touched on just about every topic there in terms of the Internet of Things. Michaela, please, the podium is yours.
Well, I was very pleased to hear the plenary that several issues were raised, which I will address in my presentation. I do need to warn you, I come from a very different perspective. I'm actually a practicing designer, and I find myself in a very interesting situation in terms of advising on innovation policy as a result of some of the work we've been doing. My background is in design futures for the likes of Apple, Nike, and Nokia, and the co-founder of my company moved to Apple on the design of the first iPhone in January 2006, and he's still there. So we have had influence on some of the devices that have just been mentioned and some of these innovations. So from that perspective, we have been able to address some of these challenges, and I think it might be interesting for you to see from my current activities. I was one of the founders of the Alliance of Internet of Things Innovation. I was invited to be one of the founders because of the work we've done previously in IoT, and particularly in charge of the Innovation Ecosystems Group, which I co-chair with Kees van der Klauw of Philips Lighting, who is currently chair of the whole alliance, so I'm taking care of the Innovation Ecosystems Group. The reason I was asked to do that is because in 2014 I helped define what innovation ecosystems were and how they worked. There were some principles we were doing as part of CAF, Connect Advisory Forum, and I was then in charge of the Internet of Things business models. And my principal aim with all of this was to actually test these assumptions. And so even though programs for IoT that would allow us to test these assumptions weren't ready, we did something unusual, and we went through the creative unit, which is more open to new kinds of ideas, to testing of new kinds of ideas, and launched an innovation action from within the creative unit which tested the building of an innovation ecosystem and several principles. And the results of that were really surprising. So what I'm going to do is, first I'm going to tell you the work we've been doing with the AOTI in terms of recommendations that have influenced the digitizing European industry policy. Then I will run you through what we did in our early test beds and what we have learned from that and the results. And then the recommendations that this has filtered through in terms of Connect Advisory Forum. And we've currently completed the innovation recommendations from that group, a whole set of innovation recommendations and the overall Connect Advisory Forum recommendations, which obviously influence this space. So the AOTI was founded in March 2015 in the presence of Commissioner Oettinger, and they had 44 original founding members, cross-section of industry verticals. It has now over 500 members and a very high presence of SMEs, over 60%, which is its main USP. The organization has now been incorporated as a new legal entity with approval of the Belgian King. This is literally a few weeks ago, and it has 13 working groups. These are the AOTI 2.0 founding members. So you will see a cross-section of industry there. And the mission statement still remains the same as it has in the beginning: to contribute to large-scale pilots. I'm sure that most of you are aware of this program. The development of IoT ecosystems was something that was specific to the AOTI, so which is why the innovation bit of that alliance's name. Then, of course, to promote EU spearheads, to gather evidence on market obstacles, and to map and bridge the innovation activities across member states. So this is the structure of the AOTI. It has 4 verticals, which are transversal across all, it has 4 horizontal working groups, which are transversal across all the verticals. And also it looks after SME interests across the verticals. So if we look at the cross-cutting working groups, they are the European Research Cluster for IoT. There's the Innovation Ecosystems Group, which I chair. There's the Standardization Group, which has been really active and has a huge number of participants. And there's a policy group which is currently finalizing an important document. And these are the verticals that have been active in the AOTI. Now, in the first year of its activities, it has issued a series of policy recommendations. It has been engaged in workshops. Individual working groups have met for workshops and created papers, and also obviously has disseminated their findings at conferences. So the impact, as a result of these activities, it has impacted on the digitizing European industry policy, particularly in recommending a single market for IoT devices and services, so standardization, building a thriving IoT ecosystems, so really encouraging open innovation across platforms. So you will see in the rest of my talk how much transversal activities are important for innovation. And of course, the human-centered trusted IoT, we mentioned security, we mentioned privacy, we mentioned some of these very important issues. Now, the innovation ecosystems have been focusing on the horizontal platforms. So an ecosystem that is founded from all of these vertical platforms. And traversal application of application programming interfaces, graphic user interfaces, and tangible user interfaces. Now, we'll come back to this because this has come out of some of our early testing. Agile pilots to enable hands-on experimentation. So we really want to get our hands dirty and try and test, as some of our colleagues have mentioned earlier. We really need to test this in real scenarios in order to learn from it, to test the security issues, to test the privacy issues, to test how the interoperability works. Obviously, another thing we looked at is sets of guidelines which assess levels of risk, data, openness, and adoption, and I will come back to that as well. I won't go into detail right here. And of course, the funding mechanisms, so how they're managed and how can we encourage faster deployment. It will all become clear. So if we actually look at the experiments that we conducted, as I explained earlier, my company embarked with partners, gathered partners and embarked on an early experimentation. And this is what we found. And what we found was really quite surprising, but we built it on certain principles. We said, okay, innovation models for IoT can be incremental, which is traditional industry model, because incremental innovation is usually justified in industry expense budgets. If you say, I am going to save a certain amount of, by increasing operability of data or by streamlining systems, you can justify it in your expense budgets. It's very clear. But if you say, I'm going to do a disruptive experiment, it's very hard in industry to justify where your money is going to come from. On the other hand, disruptive innovation comes from SMEs who want to actually break new ground and who can take a higher level of risk. And ecosystems, the idea of ecosystems is to unite those two sets so that we have both incremental and disruptive innovation. We have, in IoT business models, I think at the beginning when we started talking about this, this wasn't clear at all. I think it's becoming clearer now, especially from hearing colleagues speak, the awareness of the fact that we have data-driven systems, which is what Industry 4.0 is based on, but we have data-driven services, i.e. sharing platforms that have been also mentioned during the talks. Sometimes the systems and services work together. But the third layer, which still hasn't been developed until, for instance, the World Mobile Forum this year suddenly decided that actually IoT devices were important and they were a major part, not just cell phones, they were a major part of this new landscape with data-driven products. So devices and products that are enabled by IoT, and then we can have combinations of all the above. Why innovation ecosystems? why build them in the first place? Because they allow us to have hands-on engagement between SMEs and engineers from large organizations and experts from academia and from industry. We made it our business to unite all of these different stakeholders in one place. What that allows us to do is have horizontal applications. So if someone invents something over here and an expert from a different vertical is in the same room, they can identify an opportunity that they might not otherwise do. And the knowledge transfer we have experienced has been phenomenal by setting this up properly in particular ways that benefit all the stakeholders. The knowledge is much faster than having to translate peer-reviewed papers from one vertical's jargon to another. Now, we gather diverse stakeholders, as I've just mentioned. We benefit from the crossovers and spillovers that occur in these environments, and we have used in this first experiment creativity as a social glue very, very effectively, because it was a neutral ground where people came to and started to experiment. It wasn't a particular vertical that we brought all the other verticals to. So, some of the value chain that has emerged out of this. First thing we did was devise a components toolkit. We took the results of research. We created interfaces, i.e. APIs, GUIs, and TUIs. In the IoT space, please mind the TUI space, the tangible user interface space. It's incredibly important because it allows you to take the data into the real physical space and give it to developers, to creative developers or innovators or entrepreneurs who will actually embed that in products and test it. So this allows you to bridge the great results we have from research to industry. We then seeded ideas with this new toolkit. So if you give someone a microboard, such as the one that you see, this was the first version of it, postage stamp microboard, low latency for sound interaction, sound and signaling are suddenly becoming really, really important in this space because they are a lot cheaper than having to install cameras and screens. If you give this to developers, suddenly they can do completely new things. And they can apply it with their imagination to any kind of vertical. And suddenly you see a huge amount of potential and different types of applications. We then incubated them to first level prototype. We had 11 successful results from our test beds, from our early creative test beds, incubated them to prototypes. Those then, some of those became product platforms, because once you embed something in a new type of product, you can start seeing different types of applications that can build around that product. And therefore you can engage other people to create creative content. Typical example in the past being, for instance, the iPhone, but we will now have to engage your imagination to imagine other scenarios. Now, 3 test beds. Creative test beds, where we seed ideas. Industry test bed, we take them to prototyping, and we already engage industry partners when we do that. And then market test bed, where we do feasibility studies. It's that way round. We don't do feasibility at the beginning because we don't know what the results might be. You can do a market analysis at the beginning, but I think in our plenary, the colleague from the US Steel was actually saying that they had a problem with doing market analysis at the beginning of a project and then having to do it again later on because it wasn't valid anymore. The one thing that, well, actually 2 things that really enabled us to have tangible results were new guidelines. In our proposal, we said, okay, we accept that technology readiness levels are important. However, they are not the only thing, the only driver that we need in order to succeed. The reason being that we are not building NASA rocket ships, which are incredibly expensive, which only deploy 4 people to space at the end of it, and which only collect data after the event. What we are doing is deploying quite often low-risk applications which can be tested on early adopters, and that can generate early data which already registers as value for the investors. So we need a faster system, and I'll come back to that. The other thing we did was completely rewrote the consortium agreement. We introduced a layer of innovation IP. We distinguished between background IP, research IP, and innovation IP. It was very clear for early adopters and for creative developers who joined our test beds where their IP lay. When they invented a layer of IP that was theirs, it was very clearly distinguished, and therefore it enabled them to, in record time, register patents, and I'll come back to that. So the incredible thing about having a new type of toolkit, it registered so much interest on social that we had over 5 million social impacts by the end of the project. And we started hitting really high figures at month 5 to 6, which was from 500,000 to 1.5 million. Then we thought, right, this is really kind of spiraling out of control. We had 33% female innovators participate in our testbeds, which we are very proud of, because usually when it comes to anything to do with engineering innovation, the percentage is usually half that. And then the knowledge transfer was just, as I mentioned earlier, incredible. And you will see, for instance, one of the quotes there from one of our participants. Completely as a byproduct of this process, we were in innovation action. We weren't aiming at research results. Specifically, even though the research community was very, very key to this process. We had 5 peer-reviewed papers in 12 months as a byproduct and 2 book chapters. And this came from the fast knowledge transfer. It's just simply people were just churning out new knowledge. And you will see the quote there from one of our research partners as to how important this space was for them. We had, in terms of economy, 7 tools were added from industry because they realized how fertile this ecosystem was, and it was much better for their IP to be embedded in this ecosystem than to have to promote it separately in isolation. 11 products were supported to seed prototype. We ended up with transversal applications, health, lighting, science, lifestyle communication, and heavy industry. This was a really interesting result. 7 exploitation layers were identified. You can have a look at our sort of reports. I mean, don't want to lengthen this presentation, but the first patent was filed in under a year and actually targeted forestry and agriculture, which was totally unexpected. So this was the timeline. This is how fast this went. We had no toolkit in January 2015. By the end of month 5, we ran our first creative test bed. We tested the toolkit, including the first microboard. We had the working product prototypes. Some of them were completed by month 9, so I believe 4 of them were completed by month 9. The patenting search was already conducted at the end of that month for one of them, and patenting initiated in month 10. The patent's been filed. So, few recommendations for you. And these have been now passed under the innovation recommendations as well. First of all, we update the IP contracts. We need to set our guidelines so that they actually facilitate things later. If not, we will hit a roadblock with IP. You can give people stuff to develop. If your contracts are not set in the right way, suddenly you will have that blurred line between what is mine, what is yours. We have very clear guidelines for that. And it facilitates open innovation. So open innovation doesn't mean open-ended. It just means that there are tools accessible to everyone to use under very, very well-defined guidelines. We have introduced market adoption readiness levels. This has been passed by CAF. It was passed by CAF first time round, a second time round now with evidence. It's also been passed by the AAOTI. And it's one of the top recommendations now, innovation recommendations. We look at level of risk that an application carries as an idea. So for instance, if we are dealing with health, we need to really be careful, and we cannot obviously release things to early adopters if they are not ready or if they are likely to cause harm. So we need to have a really good assessment. But a lot of what we do can be released very early and can move the economy. So we want to release it to early adopters. We then assess the potential of early adoption, how much of that can add value to the product, how much data yield we can get from this, and then, of course, also what are the technology readiness levels. Sometimes TRLs 3, 4 can be good enough for early adoption. We encourage horizontal development of applications because an idea developed in one sector would not occur to engineers from another sector, but sometimes it can inform them in very, very useful ways. And we have seen that as in our patent, which originally wasn't aimed at forestry agriculture, but it's now on the uptake by that industry. Cross-disciplinary networks of communities, enablers and facilitators. This is obviously very important because of how much knowledge is required in order for us to really solve our problems. Support research to interface processes. So develop the interfaces. Sure, I'm right, so towards the end now. So I already mentioned the interfaces that enable you to port knowledge from research to the developers. Run pilots. So we mentioned the 3 types of pilots. These are the 3 stages that we ran. They worked really well. So this is one model that we developed that works so far. Obviously, other projects or other consortia may develop some others. Introduce effective checkpoints and qualifiers. We really want to move things quickly in this space, so we are very keen that the way that the projects are administered are through smaller checkpoints, smaller, less risky checkpoints, so that we can filter through the success at a much faster pace. And we don't invest huge amounts of money in projects which may actually turn out not to be particularly impactful at the end of the day. And this is one thing that we cannot ignore. Administrative practices that underline any of our processes. Well, you know, this is a given, but usually gets overlooked in our discussions. We cannot build bullet trains on tracks which have been laid for steam engines. If our administrative practices do not allow us to engage in this agile and open way, then of course we cannot implement some of these high-level ideas. Typically, to illustrate this point, we were writing a PhD's worth of reporting at the end of our project, some of which was valuable. But at that time, all of our big industry partners wanted us to write business plans. So we should really look into what we are asking these projects to produce at the end. Thank you very much.
Thank you, Michaela. Thank you, Michaela. I appreciate that you had to add extra slides. Thanks to the organizers. So we have a few questions I see already from the Slido, but I'd like to start putting a question to all of you, and you can choose who goes first. How do you bring industrial companies to the Internet of Things, or does the Internet of Things bring itself to companies through the multiple devices that are now engaged? Because I realize it's quite a challenge, and what I mean by the industrial companies, I'm thinking more the medium-sized companies or the smaller ones. Who'd like to go first?
So tomorrow there'll be the next presentation to the Small Medium Business Festival in Prague, where the similar topic will be discussed. I would say the small companies, for them the cloud computing is the big opportunity. The digital transformation is enabler for them with low investment, creative idea, disruptive business model to come and attract the customers from one place immediately. For the existing incumbents, and doesn't matter if it will be bank, insurance company, I don't know, energy, utility provider, whatever. The digital transformation is something which will happen. They cannot close their eyes and say, let's wait and we will see, let's maintain our existing model. Because those companies will not exist anymore. From the 500 top Fortune companies, this is the IDC research study which was trying to say how many companies will be on the market in 20 years from now. And they found a really, I'm not able to say exact numbers right now, but it was a really amazing number of the companies which are right now the startups, and they will become to be in the 100. And the companies which are in 100 for more than 80 years, and they will not be there anymore. So it is a challenge, and it is the opportunity. For the small, medium companies, it is the opportunity. Of course, those, and this is the another aspect of cloud computing, those who will be able to get the dominant position, like Uber, for example, will be able to really compete strongly from one place with one global application, and it will be very difficult to make a startup and think I will become the new Uber. So for those companies, it is right now to think, because those who will be not starting fast enough, it will be very difficult to occupy the position later on the market.
From my perspective, if I think to the manufacturing environment, I see two opportunities for SMEs. One as a producer of IoT solutions, since the large enterprises usually focuses on the infrastructures or on the devices themselves, while the solution, so the small app which has to be provided at the end user, is often developed by startups or smaller companies. For small manufacturing SMEs instead, I see again a big opportunity by the fact that now technology is becoming really much more accessible, first of all. Second, most of the developments in the Internet of Things are in a form of apps. So things that are simple, small and focused. And actually is what usually SMEs really need. They don't really need a large big system that does everything. They need something that solves their single stomachache in that moment, at least to start with. So I think this is an opportunity also for all the companies, all the SMEs who has not yet taken some of the opportunities that digital age is already offering since years, to take them now with a different form, with a different hardware, with a different solution, maybe on the cloud, maybe on local server, if I don't still trust the cloud, because unfortunately many people don't still realize the value of it. And I think this will be an opportunity for SMEs. And I have to say, with the correct input, so making people talk about the opportunities, Industry 4.0, the IoT and so on, SMEs are interested, so they come and ask. So I'm pretty positive.
Okay, good. You said there, Jacopo, just simple, small, and smart.
Yeah.
If I got that right. Michaela, can I put it to you or ask you there? Is that where design comes in? Is that where, in your experience so far and what you've been doing, design plays a very important role?
I think I mentioned how crucial TUIs are, tangible user interfaces, in the IoT space. I said that right from the beginning when people were going, tangible what? You know, and actually I suspect a lot of our audience haven't heard that term before either. It is an incredibly important space. It's not just apps, because you have to remember that you're talking about apps which would then have to subscribe to a particular platform that's a proprietary platform currently. So we have, you know, I mentioned I was involved with Apple, and obviously Microsoft has its own, and Google has its own, etc. People who are developing these apps like Uber, they have to sit on those platforms. That's one type of thing where creativity has shown to be really important and where has generated a huge amount of revenue for the developers. But in the IoT space, I mean, of course, some of these use data and use data from real location-based data. You mentioned Uber, Airbnb, and they all need location-based data in order to function really well. But the tangible interfaces now that we're building, including all the microboards that are really enabling this space, is really the growth area. And we have only scratched the surface in terms of what can be done there. Creativity there, of course, again, is very important. If you imagine the kind of IoT space being a giant app store, open app store at the moment, all of the individual creative devices that are generated for that space work in the same way as apps do on the phone platforms.
Thank you very much. I was just looking towards this more accurately. I see there were two questions there really relate to the place of the work on the factory floor in the manufacturing environment. So I'd like to take from both of those questions, for those whose jobs are not eliminated, if you like, or people who are adapting their jobs, what will their experience of this be? What will their role be? And then from that, a second part of the question will be, what 3 new jobs might be newly defined or changed? I think that adapts the last question there. Could I start with you, Jori?
let's say, because we said that in the plant, in the production line, there will be a lot of embedded computing things, yes, and it will be necessary to service them, yes, to set them, yes, to maintain them, to program them. So I think the new jobs will go there instead of, let's say, operating machines, yes, stamping machines or other type machines in the machinery. You should have the people which are able to set and program them. So that will be the change which will be happen. The problem is, of course, it's not so easy. Yes, it's not so easy because it needs a lot of new knowledge and skills and training. So this is a challenge for all the society, how to make this transformation in the current staff of plant, and of course how to prepare new people. I know, for example, the automotive, yes, here in Slovakia and also in Czech Republic, they are already preparing, yes, the students in the vocational schools are preparing for Industry 4 platform. But that's only one part of the industry, because they have already that vision that the new production platform will come. So, but also with a digital type of education, simulation, I think these things are possible, and to make it accessible also for the big parts of the youth population.
Any further thoughts on that?
It is a really interesting question. What will left for the common workers? Because we are just thinking to the near future, which we can still imagine. But I don't think that most people have the brain, as Jules Verne had, able to think 50 years from now, when the robots will really do all of the common work, where there'll be no poverty, there'll be, in fact, the higher level of standard of living. Everybody will be fitted. There'll be no need to go to work. Maybe the Finnish model, which they were trying to introduce, I think, was it in Finland, that there'll be some minimum average salary, or not average, minimum salary, which will allow people not to work anymore. They should work for just be interested to do what they would like to spend the time on, just maybe to get a little better level of living. But this is a really question which will have to be solved. Will there be some special taxations introduced to make the profit for the governments to be able to introduce such kind of social programs to allow to do that? You know, and this is something what we have proven by the surveys, that the students which are just now coming to the secondary schools or to the universities, they are studying for the jobs which will not be available at the markets when they will be in the business. They will have to transform as they will learn. So this is for sure that those new job descriptions, they will evolve, they will be developed in the time. Maybe we have some thinking what kind of professions will be needed, but the real job description of the future jobs, they are unfortunately not known to those who doesn't have this long-term vision.
Thank you very much. I'm just conscious of the time as well, and the audience who are been patient. Does anybody have a question they'd like to put to our panel? Yes.
Okay, hello. Good afternoon. This is Eduardo Beltrán from Mondragon Corporation. Just a question to the IoT representative. So you have been speaking about standardization. So I would like to know which kind of activities are you developing in standardization, if you are doing it in coordination with IEC, with ISO, Sensenelec, or which kind of groups, or a little more about the standardization. Yeah.
It is absolutely massive, our standardization group. So it's done in conjunction with all of the other existing things. It's coordinated by ETSI. There are several subgroups as well, which are focusing on all these different activities. So they are drawing all the intelligence from all the different other activities. The best way, if you're interested in standardization, is to read the papers that we're constantly having to update their papers as well, because they're constantly churning them out. And also, if you're really interested, I can put you in touch with the leaders of the. There's actually several. There are people who are, because it's so big. There are actually several people who are engaging all the stakeholders in this.
Okay.
It's
Thank you
really,
very much.
but I mean, you can be sure that they are covering all bases. It's probably one of the biggest groups of working groups ever. Several hundred people are members.
Well,
Thank you both.
lot of-
Conscious again of time, but also of this device leering behind me. There is one issue that's everyone has to be conscious of course, and many of you touched in your presentations, and of course, people are used to hearing this, but it's something we should discuss and think about, is security. Because only a week or so ago, there was, as you are probably aware, I suppose a DNS of form attack. It took down a large number of websites. Sure, that wasn't exclusively inside a factory, but it represents an example of the potential hazards that presents for the operational factories, for companies of different sizes, for the big guys, for cloud providers, but also for the consumer, who is, in a way, will probably give away a lot of data or their own information in their interaction with new products, in their shopping and so on. So how do we, or what are the big challenges that we need to overcome in that regard for security? What steps could we take, or are you thinking about taking?
Yeah, I think this is really something which is in the core of trust of the cloud services, and the cybersecurity, in fact, has to be split into what we can do as a preventive things, the advance, and unfortunately, the technology is developing so rapidly that the cyber attackers, they are always faster than the defenders. Within the Microsoft, there was 5 years ago developed the Digital Cybercrime Unit data center fighting against the existing botnets. So the botnets are the network of infected computers. The Internet of Things was one of the biggest botnet attacks in the last week. But there were a couple of botnets in the past years which were focusing on the personal data, on the banking account, on the different kind of valuable information. So the viruses are not anymore those black, blue screen lightning, the virus affecting the hard drive. They are rather the silent horse Trojans, or the agents who are trying to get the most valuable things from your computer and monetize it on the black market. We have a program which is called Cyber Threat Intelligence Program. CTIP program is available online, the data of all infected computers of the botnets, which were analyzed. The control command servers were taken away from the attackers, and the future algorithm allow us to take control about all of those infected computers. We are sharing those data through the government security programs with the different national security agency, including here in Slovakia. The CTIP program is already running, and this is one of the most valuable data the national security agencies can have in terms of fighting and identifying the real cybercrime people who are making a huge amount of money on developing those botnets. So this is the things where the cooperation between the business and the law enforcement is very important, and just to be able effectively fight against the cyber terrorism on the global basis, because usually those cyber terrorists, they are attacking from the different jurisdictions, and they are trying to use the benefits of not being potentially responsible in the territory where they are doing the things. So all of those things will have to be very flexible, and the law enforcement cooperation on the global basis will allow to stop at least part of those activities.
Any other thoughts on the panel?
I will also add that the issue is that we need to have practically for every domain the security architecture, and that's the key issue. I think still the knowledge and skills on this area is not enough in the world. There are coming a lot of new systems connecting without let's say any prevention, any good design. And that's the issue. So, yeah, exactly this.
Okay, Michaela, any last quick thoughts on this?
Well, it does bring me back to your presentation and your photographs of cars. And if you think about the level of security we had on the roads in 1925, you can probably then think of where we are with that at the moment. This is how much we need to still go, to get somewhere where it's really safe. Need to live and learn, I guess.
Absolutely. Yeah. And Jacopo, any last quick thoughts on this?
Actually, is again from the point of view of manufacturing companies, where I think they are still waiting to check and see what is getting there, and they are extremely afraid of people getting to their manufacturing equipment and stop them. After what happened with the virus for PLCs that was released some years ago, they are even more scared, but I think it's a matter of letting them know, letting them understand what's going on, teaching and training. The data sharing, so the privacy for them is a big issue, but again, if they see the benefit, as we do as consumers, we allow Microsoft, Google, Apple and so on to have some of our data because they are also providing us good services. If the exchange is fair, I think it will work.
Okay, so there are a lot of challenges, but there are also many opportunities. Well, that's it from us for now. Please continue the discussion if you like afterwards. I'm sure there'll be some networking. Thank you very much to the panel, and thank you all for the audience.